Today I want to cover how to create a private Debian packet out of a package that you have in your system. So a requirement is that you have created a packet, that you have these source code files, and yes, we will install some command line tools, and I will show you step by step how this is done. Hello, I'm Roberto from The Construct. I will be using the online platform from The Construct where you can learn robotics. So go to theconstructsim.com and log in with your account or create a new account. And then you will see an image like this. I also created, I just placed a link on the video description that when you click it, you will get the same project that I'm showing here. So it will open automatically, and then you will have the text that I prepared here for showing this, how this is done, and you will have the same files on the IDE so that you can follow along. Great. So what I wanted to do as first thing is to run a demo so that you can see the package that we're going to create a private Debian from. So to run the package, you can follow the instruction here. Basically, I'm building the workspace and then sourcing it, and since we're using the TurtleBot3 robot, I need to set 3 environment variables, which are, that was the first one, this is the second one, and this is the third one. So this is specific to the simulation that I'm running, because I need a simulation running in order to be able to show you the functionality of this package. So I just run this launch file that now it's starting Gazebo. Here you have it with a robot, and this is just an empty world, and the robot is here, this white dot. So the package itself is, I will run it now. It's called ROS2 draw squares. So this is the command, ROS2 launch command to run the package. And well, nothing has happened because this is just service server running. So using the command line, I can just call the service, and then we will see some action. So I do this ROS2 service call command. This is a trigger message, and just by executing this trigger message, these servers gets activated, and you can see the robot moving forward. Now it's turning left, moving forward, stopping, turning left again. So basically it's a service server for moving the robot in a square. That's just a very simple package to demo, to use it as a demo for creating a Debian file. So that's basically the demo. Oh no, I can close. I don't need this. I don't need the simulation. So now let's do what this video is all about: how to create a Debian package from from a package that I created or I have on my system. So, but what is a Debian package? A Debian package, basically think of it as a .deb file that contains all the other files or the files that normally your package has. So in this case, we have a header file. We have 4 different source files. We have a launch file. So all of them get packaged into one Debian file, and this is great because you can distribute this file and others can install them on the systems, and you're not giving away your source code, just this Debian, which is a binary file. So okay, let's start. How do we create a Debian file? Well, first we need to install some tools, and I will use apt to do so. I just did an upgrade, and now we're going to install Python 3-bloom and Python 3-rosdep and fake root. In this case, I didn't need to install anything because they are already installed and up to date. Great, so first step that you need to do is to verify that you have this package.xml with all the dependencies in it. So this is the root of the root directory of the package. The package is named ros2 draw squares, and you know, as always, you have this package.xml file. I'm showing the content here, and basically I have 4 dependencies: RCL, CPP, standard messages, geometry messages, and standard services. That's all what I'm using inside this packet, so it's fine. I don't have to change anything. But if I was using a different dependency and it is not listed here, well, that's not good, because you won't be able to install the Debian file if it cannot resolve the dependencies. Okay, next step is to initialize rosdep. You do it running this command here, and normally you will get this error message. It's just telling you that it was initialized before rosdep, so it's okay, you can ignore it, it's fine. Great. The next thing is to actually create the first step of the creation of the Debian package is this command here, bloom-generate rosdebian. Okay, we run it. It's already done. Let's see what it did. It created this Debian directory, which wasn't there before, and created some files and directories in it. We're not going to touch that because we're going to run the second command. This is the command that actually will create the binary file. It's the fake root command. Let's run that, and this can take a while. Let's see how long. Oh, that's it. Not that long. So let us see here. We have this Debian directory that we created using the first command. But wait for it. If we move one directory up, we will see we have this .deb file. Actually, we have 2 new files, but we're interested in this one that is in red, which is the binary file. that's it. We created binary file. So that's it for this video. But no, I wanted to show you also how do you install this Debian package in your system, because that's why you're creating it. I mean, you can copy this file to a different system, and then you need the dpkg package management program to install a Debian file. You can use other programs, but I will show you how to use the pkg. So you run sudo dpkg install and the name of the Debian file. That's it. Very quickly, it did the installation. So now I want to know where in my system are these files. So in order to do so, we need we can use the pkg and the info option and the Debian file. This will give us the name of the package. Basically, that's the name, ros-galactic-ros2 draw squares. That's the name. And when we have the name, we can use dpkg again, using -l to, and this will show us where the files are installed. Basically, here you can see it on my screen. So what's important here is that they are installed in the same location that the main ROS2 installation is. In this system, it's in opt-ros-galactic, and there it is, just where other ROS2 packages are that that you installed from binary files. So that's it for today's video. If you liked it, please give it a like or share it. Subscribe if you haven't done so, and see you in the next video. Bye.
The ROS2 intermediate course covers how to create launch files for ROS2 using different formats, like for instance Python, XML, or YARN. You will also learn how to work with parameters in ROS2. The course also covers how to manage threading in ROS2 using executors, or how to handle callbacks using the callback groups. You will also learn about a couple of very important concepts in ROS2, such as the quality of service and DDS. Finally, you will also learn how to work with managed nodes in ROS2. Start learning now.